Welcome back. It's time for math. I'm Miss Aker. Let's jump right in. Remember Frankie the fraction frog? Numerator's on top, so I hop, hop, hop. Denominator's down, go to the ground. Let's jump right in with Just Know It. That's the part of math class where you know it just like that. And we are going to warm up with some comparisons. You can compare all kinds of things in the world. Something might be bigger or smaller, louder or quieter. And we are going to use some symbols to do our comparisons today in math. We are going to be using the symbol greater than, and you can make the symbol at home too with your hands, just like that, almost like an alligator wanting to eat. Nom, 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 nom. This symbol says greater than. The other symbol we're going to use is less than, and it looks like this. Can you make your hand like that? Nom, 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 nom. And finally, we can also use the symbol equal for equal to. And we can just make our hands line up just like that to show that they are equal. Let's give it a try. You use your hands as the math symbols at home while I hold up the cards on the screen. Here we go. 3 versus 1. I think you know that one. Let's try the next one. 15 and 10. Okay, you could do this one. 2 plus 1 versus 2 plus 2. Which one's greater than or less than, or are they equal to? You tell me. Okay, here comes a fraction. 1/3 versus 2/3. What do you think? Here's another fraction. 1/4 versus 1/3. You got this. And finally, 1/2 versus 2/4. What do you think? Did you use your symbols? Greater than, less than, equal to? Let's check your work. 1 versus 3. 1 is less than 3 and 3 is greater than 1. Nice work. 10 and 15. 15 is greater than 10. Okay, I tried to trick you here, but you're too smart for me. Which is greater than? 2 plus 2 is greater than 2 plus 1. Time for a fraction check. 1/3 is less than 2/3. Okay, one way to think about this, would you rather have 1/3 of the pizza or 1/4? 1/3 is greater than 1/4. And finally, show me what you got for this. You got it, 2/4 equals 1/2. Nice work. Now it's time for our next part, which is figure it out. For our figure it out word problem today, we're going to do 4 things. We're going to read it, think about it, draw a model, and write a sentence to show our thinking. Are you ready? Let's start by reading. A recipe calls for 1/4 cup flour. Keyshawn only has 1/8 cup measuring tool. How many 1/8 cups will equal 1/4 cup? Okay, check. We read it. Now it's time to think. This seems pretty important that we have a 1/4 cup. We need a 1/4 cup, but we only have a 1/8 cup. So I know that that's some really important information. And I want to know how many 1/8 cups will fit in a 1/4 cup. Okay, let's start drawing our D. I'm going to use one of our models from last week. I think I'll try the area or bar model. So I'm going to start by drawing my bar. I'm going to make it into 1/4 cups. So I have 1 line, 2. If I want to show 4 parts, I need to draw 3 lines. So now I have 1/4 cup, and I'm going to label it. So anyone who looks at this knows what I meant there. But I only have 1/8 cup, so I need to show 1/8. So I could cut this in half, and now I have 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. Now I can see that I will need 2/8 to equal 1/4. We figured that out. Way to go. But you know what? We forgot one step. We drew a model. Let's write a sentence to answer this question. How many 1/8 cups will equal 1/4 cup? 2 1/8 cups will equal 1/4 cup. 2 1/8 cups equal 1/4 cup. Now we've done all our steps. Read, think, draw, write. Now it's time for What's New? The part of our lesson where we find out what's the new thing we're going to work on today. Let's read our learning target. I can use benchmark fractions and models to compare fractions. Okay, I know some of these words. We worked on comparison today already, and we worked on fractions last week. Let's break it down. So I can use benchmark. That sounds kind of new. Let's come back to that. Fractions. I know what fractions are. Fractions are a numerator over a denominator. The denominator tells us how many parts make up the whole, and the numerator tells us how many parts we have. And models, so models we know are drawings to help us show our thinking. To compare fractions, well, we know that we can compare with greater than, less than, or equal to. And we already did fractions up here, so I'll draw an arrow. Well, it seems like the thing that's new today is benchmark fractions. So let's talk about it. Benchmark fractions are very handy. They can help us know and visualize where any number of fractions might land on a number line. Here are some examples of benchmark fractions: 1/4, 1/2, and 3/4. These are pretty common fractions. We can easily find them in our bar model here. Here's 1/4, here's 1/2, and here's 3/4. So today we're going to practice using these benchmark fractions to think about and compare fractions with one another. To get started with What's New, grab a piece of paper or a marker board and a pen or pencil, some sort of writing tool you can use to follow along. We are going to work on this word problem, and just like we did in our Figure It Out, we're going to use those 4 steps to help us make sure that we're covering and solving all that the problem is asking us. So let's write that off here to the side. R for read, T for think, D for draw, and W for write. Let's start with reading. Jamari and Dominique both got a cheeseburger and Takis for lunch. Jamari ate 4/6 of his cheeseburger. That seems important. And Dominique ate 4/5 of the burger. Who ate more? Okay, well, we read it already. Let's think about it. We want to know who has the greater, who ate the greater amount. So let's start by thinking about a model we could use. So a model that we could use is a bar model. So let's start by making 4/6. Well, I know if I want to show 6 parts, I need to draw 5 lines. So 1, 2, 3, 4, 5. I'm going to put a J over here to represent Jamari's burger. And I'm going to make another burger underneath, even though it's not really a burger, it's a bar model representing a burger. I'm going to put a D next to it for Dominique, so I can see Jamari's and Dominique's. Now Dominique ate 4/5, so that's different. That's 5 parts, so I'm going to draw 4 lines. 1, 2, 3, 4. It's really important that I make sure that when I'm comparing fractions, that my models are the same size, because they both had the same size burger, but one ate more than the other. Let's shade 4/6. 1, 2, 3, 4. And let's shade 4/5. 1, 2, 3, 4. As you can see in our fraction, in our bar models, we proved that this 4/5 is greater than 4/6. So we could write it like this. 4/6 is less than 4/5, or we could write 4/5 is greater than 4/6. Both are correct. Now, one thing I'm noticing here is that the numerator was the same. And when the numerator is the same, whichever denominator is smaller is gonna be the bigger amount. Think about why that is, because the parts are bigger. This 1/5, 1/5, 1/5, 1/5, 1/5, that part is bigger than these 1/6 parts. It takes more 1/6 to fit inside the same hole. So if we're comparing fractions and the numerators are the same, we can look at the denominator. And whatever denominator is smaller, it's going to be a bigger amount. The smaller the denominator, the bigger the part. The bigger the denominator, the smaller the part. Let's try another one. R, T, D, W. Eloise, Roxy, and Noah were knitting scarves. They all included the color blue. Eloise's scarf was 1/3 blue. Roxy's scarf was 3/4 blue. And Noah's scarf was 2/3 blue. Whose scarf has the most blue? Whose scarf has the least blue? Oh my goodness, there's 2 questions in here. We read it, check. Let's think about it. I see a benchmark fraction. That gives me an idea. I'm going to use a number line, and I'm going to draw my benchmark fractions to help me visualize who used the most and the least blue. I know right in the middle of my fraction, of my number line, is 1/2. Start at 0 and 1. That's my first major benchmark. Now I'm going to draw the others. I know 1/4 just like that, and 3/4 just like that. Well, that's where Roxy is, so I'm going to put an R on Roxy. Roxy is right here. She used 3/4. Well, I know that 1/3 is not bigger than 1/2. I know that it's somewhere right in here. So I'm going to put an E here, because I know that it's between 1/4 and 1/2. And now that leaves me with Noah. I know that 2/3 is bigger than 1/2. I just need to know, is 2/3 bigger than 3/4? So I could figure this out on my number line, but I want to make sure that I'm measuring and showing my, my model and comparing it on the same size. So just to be safe, I'm going to do what we did on the last one. So I'm going to draw my bar diagram and shade 3/4 for Roxy. And I want to make sure I do 2/3 for Noah. And I can see here that while they're really, really close, 3/4 is just a little bit more than 2/3. So I can see that 2/3 is less than 3/4. So now I know that Roxy has the greatest amount of blue and Eloise has the least amount of blue. Let's double check our steps. We read it, we thought about it, we used 2 models. Let's actually write it out because we want to make sure we answer the question ATQ. So at the bottom, Whose scarf has the most blue? Now, anyone who looks at our work will know exactly what we discovered using and comparing fractions on the number line and with our bar model, RTDW. Way to go on our What's New. That was some excellent problem solving we did with read, think, draw, write. And now it's your turn to try it at home. We're going to be using some fractions, some bare number fractions, to prove and show our thinking about what is greater than, less than, or equal to. So remember our learning target? I can use benchmark fractions and models to compare fractions. That's just what I want you to do with these bare numbers. You can imagine that it's a piece of pizza or that it's measuring sugar for a recipe. When you think about a real-world example, it sometimes helps you with these bare numbers. So think about what model you want to use, a number line, an area or bar model, and think about how you can use a symbol to show which one is greater than, less than, or equal to. I can't wait to see how you do with this. I can't believe it's already the end of our lesson. And you know what that means? It's time for me to say goodbye. But before we go, I want to teach you another fun way to call and respond. Last week, we learned firework high five. Shh. Today, I want to teach you something really cool. Get ready. I'm going to say cool, and you're going to say way cool at home. Here we go. Cool. Way cool. Great job today, everybody. Thanks for watching.